If you look at this question, students, if omega is an imaginary cube root of unity, if that is the case, what is the cube root of unity? Formulas are related. 1 plus omega square is equal to 0. Omega cube is equal to 1. Then what can be one of the possible values of x as the question asked? Correct or not? So what we'll do, C1 transforms to C1 plus C2 plus C3 if we do the transformation. We'll end up with 1 plus omega square plus x. 1 plus omega square plus x. And 1 plus omega square plus x. Is it correct? Omega square 1 plus x, and then x plus omega and omega square, that is equal to 0. Now if you clearly see 1 plus omega square is 0, right? 0, this we know. So we can write here x, omega square 1 plus x, and x plus omega and omega square should become equal to 0. Carefully see, if the value of the determinant should become equal to 0, it is possible only when x takes the value equal to 0, right? If any row or a column of the determinant is identical, then the value of the determinant should be equal to 0, which means any one row or column of the determinant is 0. So what is one possible value of x? Definitely that value of x can be 0 is the answer to the question.